Sci Access, May 10, 2024. 3D printing programs at schools for the blind. What has worked and how we are collaborating to create solutions. Caroline Karbowski.
Hello, everyone. My name is Caroline Karbowski. My pronouns are she, her, and I'm a white woman with brown hair that's shoulder length. I'm presenting on 3D printing programs at schools for the blind, what has worked and how we are collaborating to create solutions. I'm the founder and CEO of C3D, 3D Printing for the Blind. It's a nonprofit that's based in Ohio in the United States. Our email is info@c3d.org. That's INFO @SEE, the number 3D.org. And if you email that, I can also send you the slides in various file formats. I have the C3D logo on the screen, and it's the letters C3D being 3D printed, as well as the Symbraille for C3D. And behind that is a colorful model collage, including models such as butterfly, snowflake, eye, brain, castle, and even a train. So why do we focus on 3D printing at C3D? Well, blind people need access to visual concepts. You can't touch everything because some things are too large, small, dangerous, or delicate to touch in real life. But with 3D printing, you can feel models to understand what things look, how they look. So I have a picture of a real fire and then an arrow pointing to a 3D print of a fire. And while conceptually fire is more than just the shape or the flames of fire, the 3D print does give us a basis for what that visual concept looks like, and then you can build upon it, learning with additional sensory modalities. 3D printed models can also be easier to produce, less expensive, compared to traditional model production methods, such as things like wood carving or injection molding. I think the best thing about 3D printing is its ability to be customizable. You can take an existing file, modify it for each person's needs, and then print it in any location. 3D printing is also a growing versatile job skill. So as we're teaching students to learn how to use it for educational concepts, they can use it for future applications in engineering or manufacturing. 3D printing also fosters global collaborations and collaboration. I can have a file in Ohio and it goes to anyone in the world. So C3D started in 2017 when I was in high school. I was looking for some more applications of my Braille skills. I learned Braille in middle school so I could read books in the car without getting car sick. And then my school had 3D printers, and I thought we could use 3D printing to increase the availability of tactile models. We coordinate volunteers from all over the world to join our Slack workspace, where we post our job requests to design and print models. We've done about 5,000 models since 2017 to people in 25 countries. And we have also supported people in up now to 32 countries. The countries in blue are places where we've sent models or helped people start a 3D printing program in their area. We have found that C3D is 77% of model requesters' only source of 3D prints. And we really want to now enable more people across the globe to be able to print, so that way people can get models faster than everything being shipped from Ohio. And so that's what we focused on with our Society for Science STEM Action Grant this past school year. We helped schools and organizations for the blind start a 3D printing program because we paired them with a mentor who was knowledgeable about printing for the blind and low vision community. When I was in high school, the first school for the blind that I visited that had a 3D printing program was the Indiana School for the Blind and Visually Impaired, or ISBVI. They had 10 printers and made student and teacher model requests. I was really impressed by what they had there. They had these huge models. They had a Mount Rushmore, which I have a photo of, and the heads on the Mount Rushmore are the sizes of human heads. They had a model of their school made out of 8 pieces, and it had tactile markings for roads, sidewalks, and buildings. And then they had a model of President Benjamin Harrison's house, where it was like the floor plan, and then had walls and doorways that were to scale. Then you could stack all the floors and the roof, and it would make a real house. And so I took that idea to the Ohio State School for the Blind when I went to the Ohio State University. So at the Ohio State School for the Blind, or OSSB, they got 3D printers, and people from C3D and community members from Ohio State have been supporting the school's program for the past 6 years. We started out with 3D printing miniature models of their historic model collection, such as they had a Taj Mahal, which is photoed here, and it's on top of a piano. It's that large. And this model was made during the Great Depression. And it's so large that students can't take that home or access it after graduation. But with miniature 3D printed versions of the Taj Mahal, they could. So we made a lot of models like that. Students also wrote descriptions. We made them in print and Braille. We did field trips. We went to Ohio State's Innovation Studio. That's the makerspace at OSU. We visited IC3D Printing. That is a Columbus 3D printing company that makes filaments, printers, and models. And we also had a lot of OSSB students provide feedback on C3D prints. And during COVID, we did a lot of online Zoom work, working with Wi-Fi enabled printers, and students contacted 3D printing companies to advocate for accessible settings. So Emerald Bennett, who was involved in that 3D model club, is on Zoom today for the Q&A if you have any questions about OSSB Model Club that you want to direct to her. And she now works and is a contractor for C3D. We also at OSSB have a shelf with a bunch of models that students made throughout the years, including like models such as a lighthouse and a map of the Ohio with topography. What's exciting is when stakeholders come to OSSB, such as government officials or visitors, they are brought to the shelf and get to see all the work that students have done, which I find really exciting. So the big thing that I've learned from working with or seeing ISBVI and then doing the club at OSSB is that a lot of these programs are maybe worked with only a few people. And it's really important to share the ideas that we have and collaborate with others. A few years ago, I didn't really know of any other schools that had clubs. And during COVID at ISBVI, they actually stopped their 3D printing program because their head person went to a new job. At OSSB, we had one of our leaders retire. And so there was a period where we didn't have the club as we were transitioning leadership. And so I was really thinking it's important that we connect these clubs together so that way we can support each other when we do have leadership changes, and we can share the strategies that we had all been working on individually, so that way we can all benefit. So some accessible strategies that we did at OSSB that we're now sharing with others include labeling our printers with Braille and large print labels. We have designated spots for our equipment. So we have a box for filament recycling that's in the same spot. We have glue sticks in a designated box, and we have a box for SD cards. I have a photo of 4 cubes with different infill amounts. This is how solid a model is. And these cubes go from small amounts of infill to large amounts, and they also have different heights for the top and bottom layer. And there's no walls around the edges, so you can feel the inside. We keep our failed prints and use them as teaching tools. I have a hexagon photo model where the first layer didn't print well, and so the strands are all straggling everywhere, but it's a good teaching tool. To talk about layer height in 3D printing, we use strips of cardboard at increasingly smaller lengths that we then stack together like a staircase. So I have a cardboard staircase made with 5 pieces of cardboard, and then we have a foam staircase made out of 9 pieces of foam. Since cardboard's thicker, you don't need as many pieces to have the same height as the foam staircase. Just how in 3D printing, if you have a thicker layer, it's going to be faster to print, but your gradations are going to be jaggier, just like a staircase would be. To also convey how 3D printing is a bottom to top procedure, we use laser cut Brutus. Brutus is Ohio State's mascot. He's a Buckeye seed that's spherical shaped, and it has a face and a baseball hat. And we have pieces of cardboard that are stacked on a dowel rod, so you can build him from bottom to top. So I had an update from the Texas School for the Blind and Visually Impaired. Sue O'Brien there was one of our mentors for a school. And Sue taught computer science and used OpenSCAD. That's a screen reader accessible design software that allows blind students to be able to use code to make models. And she found a lot of success when students used OpenSCAD because they could print the model out and then feel it and decide themselves how they wanted to adjust their model. Chris Carell there also made the Accessible STEM website. This has instructions on using OpenSCAD and Prusa. This is linked in the slide notes. Also, they use the command line to bypass inaccessible slicers. That's how you take a model from the file to actually printing it. They use large monitors instead of the screen magnifier zoom text. It's because they found that the students like to be able to have all the buttons visible at once and not just zoomed into one area. It's a lot easier to minimize getting lost. They really have liked using Bluetooth and tactile calipers. The photo of the Bluetooth caliper they use, and it connects to an iPad, so then they can use the screen reader or magnifier there to access the number. They also have had a lot of assistive technology lessons, incorporate 3D printing because they found it's more fun for students. I also have a photo of a student design project. They made labels for syrup bottles for their coffee shop. The first design they did was a hollow cylinder with a Braille label that went on the neck of the bottle, but it would spin around the bottle and the label wasn't always on the right side. So they improved their design by making a stand with the Braille label, and those have been used for multiple years now. One organization in our mentorship program this year was the Helen Keller National Center, or HKNC. They mainly support adults who are deafblind. One problem they had is they wanted to know about more accessible calipers because they just had large print readouts and the other options they knew about were auditory, but that wouldn't work for their deafblind clients. So we were able to share that feedback from Texas School for the Blind and Visually Impaired to use Bluetooth or tactile calipers. And I have a photo of the Braille caliper. As you move the piece, the Braille does dynamically change, which is cool. At HKNC, they've been focusing a lot on student-led projects. Their students have been using Zoom Text with Tinkercad, which is a visual-based design program, and they're starting to learn OpenSCAD. The Virginia School for the Deaf and Blind, or VSDB, was in our mentorship program. They were mentored by Jacob Ayers, who ran the 3D printing program at the Indiana School for the Blind and Visually Impaired. They've had a volunteer coming in who's been teaching 3 low vision students Tinkercad. They're starting to learn OpenSCAD, but they would benefit from more accessible software and printers. I have a photo of their Jellybox printer that they're using, and students are holding up a wrench that they made. The Kansas State School for the Blind, or KSSB, has a makerspace class. So they're involved in our mentorship program. They worked with someone actually in Canada via Zoom to start learning Simplify 3D. That is the most screen reader accessible slicer that we know of. Kansas also hosted the Make 48 competition, where they had schools for the blind come from across the country and do a design competition. Right now, they only print for students at the School for the Blind, but they want to print for Kansas blind and low vision students outside the school. And they want to make a work program for students. I think that's really exciting. And as 3D printing becomes more accessible and we share more of these workflows, that's going to be more of a reality. Also, I have some photos of models they made, including an escalator with a turning crank so it can move, a model of a lion on an Ultimaker printer, and various blocks showing different infill patterns. We also worked with Hope for the Blind Sierra Leone. I met their leader of the organization, Abu Bakar Kamara, when I was at the NFB, or National Federation of the Blind National Convention. There's a photo of Abu and I smiling at the exhibit hall. So the resource center that Hope for the Blind is making serves people throughout the country, but specifically 3 schools for the blind in Sierra Leone. And we helped them get a 3D printer because they did not have a 3D printing distributor that would ship to Sierra Leone. And we could have mailed directly, but we were worried about things getting stuck in customs. So we were able to work with the Southern Eye Institute, a nonprofit in the US that was sending medical supplies to Sierra Leone, and they allowed us to have ship our 3D printing supplies in the extra space on their pallet. They do about 2 shipments a year, and Abu wanted me to share that if you have other donations of Braille writing equipment or tools that blind people use, that they're always welcome to include those donations on future shipping pallets. The other barrier they've had is the access to computers. Right now, we're trying to help them get a computer so that way they can also use the 3D slicers in order to work their printers. We also worked with GOP primary and middle school for the visually impaired in Turkey, or Turkiya, and they pronounce their school as GOP Yormain Yerlab or Tokulo. What's really cool about the school is they do a lot of helping teachers at like public schools or schools that don't primarily serve blind students in Turkey learn how to support the blind and low vision students that are in their inclusive classrooms. So the school is really trying to provide more accessible resources that are in Turkish. So we helped them find a 3D printing distributor in Turkey that they can then go back to for resources. And they are also looking for a mentor who can come in person to the school. A strategy they're doing is looking for Turkish engineers in the area, as well as Turkish 3D printing social media influencers. Right now, we're working with a Turkish engineer and translator who's involved in the blindness community who can support them via Zoom. They hope to have someone in person. And there's also a photo of us on a Zoom call with the leaders at the school. Themes overall that I've seen is the need for accessible workflows for blind and low vision people to 3D print, support to schools on when to 3D print or use a different production method, the need for students to have assistive technology skills such as keyboarding, screen readers, screen magnifiers in order to run the 3D printers, and tactile graphics literacy to understand how to design models, all the geometric concepts that go into that, and the other need of needing to be able to share our strategies both local and abroad. So that's why we made this mentorship program, to connect with schools and find out who is all doing these programs. So if you are running a program, or if you know of schools internationally or organizations that do 3D printing, please have them email us so that we can add them to our page, because we're really trying to make a list of all of the schools that are doing programs. Some resources of groups that are doing a lot of accessibility work in 3D printing for the blind low vision community include the Australia and New Zealand Accessible Graphics Group, or ANZAG. They have monthly calls and a website with recommendations on how to best 3D print for tactile learners. There's the Blind and Low Vision 3D Printing Facebook group and the 3D Printing Access Groups.io page. Both of these are places where people are asking questions and posting about their workaround strategies. In New York, there's the Andrew High School Braille and Talking Book Library. They have free virtual and in-person workshops on OpenSCAD and tactile graphics. And there's also the C3D resource Google Doc on our website that has links to STL files, as well as many more 3D printing resources. I started this document at SciAccess 2019 and have been adding to it ever since. So again, my contact info is info@c3d.org, and our website is c3d.org, SEE, the number 3D.org. Here you can place requests for models. You can fill out a form to join our Slack page and be a volunteer. And we'll eventually be starting a 3D printing consulting program where people can learn about best practices for 3D printing for the blindness community. And you'll be able to find resources for that on our website when we launch that program. Our Instagram is at c.3d. Our Facebook is C3D. On X, we're at C3D Printing. And on LinkedIn, we're C3D Inc. I again have our logo designed by Patrick Smith. Please feel free to reach out with me. Would love to connect with more people so we can continue to make more accessible 3D printing options. Thank you.
Thank you so much, Caroline. We do have a few questions for you here in the Q&A.
Yes.
First is from Melissa, who says, can you tell us more about recycling the filament?
Yes. So we actually started a 3D printing recycling program where people can ship their filament to us or to an organization in St. Louis called Printerior. They only recycle PLA, but any type of PLA just has to be separated. And if you decide to include C3D in your donation of the filament, then we can get discounts to purchase recycled filament.
Amazing. Thank you. The next question is from Erica, who says, question for all the people who are talking about 3D printing models. During the pandemic, I heard those are difficult to clean to avoid virus transmission in museums and schools. Do you know if this is true and if there is a solution?
So some things I have seen people do are use like Clorox wipes to wipe them. I have heard of issues where if you try to maybe eat with some 3D printed utensils, since it can be kind of porous, sometimes you can't get all of that. But for our models, though, we don't eat them or put them in our mouths. I've also heard of people 3D printing with filament that is bacteria resistant or somehow helps with that. But otherwise, it might be the same way of maybe cleaning like some toys, but I don't know a whole much. That's just from off the top of my head.
Thank you. Adrian asks, do any of the 3D models also include audio?
So not directly on the model, but we do have options where we like add a QR code separately. So it's not a 3D printed QR code. Sometimes we'll add a sticker with a QR code that you can scan for audio. I do know of other people though that have put touch sensors in the model, so when you touch it, it can talk in some way. I've also seen some really cool technology where you're touching the model, but there's a camera that is over your hands and it sees what you're touching and then can have audio that way.
Sci Access. Learn more at www.sciaccess.org.